example 2 on the book. So our differential equation system is this: y double prime plus 3y prime plus 2y is delta t minus 1. Okay, so the input to the system is delta function. So at 1, so it's 1, at 1, it's infinity. So that's delta function. So this is input to the system, okay? And see what's going on to the y, okay? All right. So since all the initial conditions are safely 0, we can assume. Okay. Then this this differential equation becomes s squared plus 3s plus 2 times big Y. Okay. And delta of t minus 1 is e to the minus t. Sorry, e to the minus s. Right? That's simple. And y is e to the minus s over s plus 1, s plus 2. Okay? And the partial fraction, 1 over s plus 1 minus 1 over s plus 2 times e to the minus s. So definitely this is, time shifting in time domain, right? So it's a time shifting, t shift. Okay, so y is inverse Laplace of big Y, which is 0, t to 1. This is e to the minus t minus 1 minus e to the minus 2t minus 2, t minus 1, sorry. T minus 1 when t is greater than 1. Okay? So the system responds like this. Or, that's probably too big. Okay? Y double prime plus 4y is delta of t minus pi minus delta of t minus 2 pi. We have two deltas, right? And all the initial conditions are not 0. The one of them is 0. The second one is 1. S squared times big Y, right? Because there's the initial conditions are not 0. We have to, be careful about the differentiation. So the first term, s times the first one is 0, so it's 0. Second term is 1, so it's minus 1. Plus 4 times big Y. And delta, Laplace transform of delta is e to the minus pi s minus e to the minus 2 pi s. Okay? So the big Y is, if you, reorganize that, s squared plus 4 plus e to the minus pi s over s squared 4 minus e to the minus 2 pi s over s squared plus 4. Okay? And this is the sine, right? Sine 2t. That's the, the Laplace inverse table, right? So y is inverse of big Y, which is 1/2 times sine 2t plus, and this is, multiplication of exponential, then it's, time shifting, right? So it's 1/2 sine 2t, but t minus pi, right? Times u of t minus pi. And the last one is 1/2 sine 2 times t minus 2 pi, u of t minus 2 pi. Okay? That's what exactly this. Right? Okay. But you got to remember, you can further simplify this, because sine 2t, the period is what? It's pi, not 2 pi, right? So this one is every pi, it repeats the same. Okay? So if you take minus pi, that is exactly the same. Half sine 2t plus 1/2 sine 2t minus pi is just 2t, right? Every pi it repeats. Times u of t minus pi minus 1/2 t minus 2 pi is the same, right? Every pi. So it's t times u of t minus 2 pi. Okay. Here. So we have 0, and we have pi shifting at pi. Here, pi and 2 pi, right? So the first pi, the first one is, this is like that, right? And second one is shifted by amount of pi. So second one starts from here, right? Okay? And third one starts from 2 pi. So, but it's minus, right? So it's minus. So like that. Okay? So each region, this is first region, and this is second region, and that's third. We get the function, right? So from 0 to pi, it's just this function, right? And pi to 2 pi is plus this 2, right? So it becomes 1 sine 2t. And here, there are 3 sine 2t, 1 over 2 sine 2t's, but 2 cancels, right? There's only 1 left. So if you write it, so y is, the first one is 1/2 sine 2t from 0 to pi. From pi to 2 pi, it's 1 sine 2t, right? And t is greater than 2 pi, that's 1/2 sine 2t.